My name is Mikhail Davydov. Today we will be talking and practicing some test design and some test coverage. But first we will try to understand what is a test coverage and what do the testers call test design. I think this is a very moth-eaten joke. Probably you heard it, but it's still very well reflect on what we are talking about. So giving you some time to read. So this joke exactly summarizes the challenges of having a good test coverage for your system, because from one of the main questions of our testing is when you should stop, because there is kind of absolutely endless number of test cases that you can write. But which of them make sense? And when you know that you're good. So we will be talking a little bit about that. But we will start with some theory. So when we are talking about the test coverage, what are we talking about? What is a test coverage? Frankly, it is a very vague concept, and there is a lot of different understandings of this term. So there is no, and it being used in the different senses. So I would say that there are two different types of what people call a cut coverage. If you ask the developer what is the test coverage, they are usually talking about the cut coverage. So what is a cut coverage? It is basically you run all the automated tests that you have, and you are checking if all the source code lines in the application had been called, and the percentage of those lines or files or branches of code, or maybe individual assembler instructions. So this is what is called the code coverage, the code coverage. So what the problem with this? Well, this way we are checking that the tests are executing your code, but we are not checking how well it is actually being tested. For instance, we can just have any assertions. We can put everything in try-catch block and call every function in your application. We will get 100% coverage. Is it a good test set? Well, I'm not so sure. The other way of measuring code coverage is with the regards of actually quality of the tests, is doing a mutational testing. Mutational testing is very interesting concept. The idea here is that basically you are modifying line by line your application, making one change at a time. For instance, you are replacing the equal sign with not equals, or true with false, or something like that. Then you rerun your tests that are testing this particular functionality, and you see if the tests are failing or they are passing. If they are passing, then we have a mutant that escaped the extermination, and percentage of those mutants are comparing to the mutants that were successfully discovered by tests, that are the tests are failed when we made those changes. This is called mutation coverage. So all this is a white box, what we call a white box testing. White box means that we have access to the source code and we are checking actually if every line of the source code is covered with tests. The absolutely different approach is taken by our testers usually. And when testers are talking about test coverage, they are usually talking about functional test coverage. As with any other type of test coverage, it is measured in percents. The question is the percent of what are we measuring. So one type of this coverage can be, we can try to understand how well functional requirements are covered with tests. And it depends on how we approach writing those requirements. It can be use cases, it can be user stories with acceptance criteria, it can be features. And then we can have something like a coverage matrix when we, for each identified requirement, we say if we do have enough tests or we don't, and measure percentage. But here the main question is how we identify all those requirements. Do we find them all? Are there any edge cases that we miss? Also, we can, the other similar approach is just to measure how many test cases do we cover. For instance, let's say we are trying to automate testing. So we have already a big suite of manual tests and we're trying to automate it. And we can measure how many of the tests of the test cases or test scenarios are being covered. In this case, we're talking about test-based functional test coverage. Does it, those figures make much sense? Not too much. First of all, we don't know if we have found all the test cases. Second, they are of different size and it's really hard to compare one with another. So it is very, very approximate indicative figures, and we're more interested in the trends, so how it changes in a time rather than actual numbers. And this is how it is different from the cut coverage. How we identify the test cases? Well, we use certain test design techniques. And the analysts, business analysts use their business analysis techniques to identify and write their requirements. But here we will be talking about test design techniques. So I can give you just a list of the names of the techniques that testers are using in their work. The most simple is error guessing, which is basically you're just looking at your application, your functionality, and thinking, okay, so what bugs can be lurking here? Or which bugs would I expect in this functionality? Okay, I know it will be this. So how would I catch that? This is one way. But obviously, you first of all, this is totally based on your experience, and it is absolutely informal. It cannot be the main way. The other is called domain-based testing, and here is the idea that when we are talking about some particular functionality, we have some inputs and some outputs. So we identify what are the different parameters, the different variables of our functionality, and what kind of the different output parameters we have. And then we're trying to understand how application behaves differently depending on which combination of those parameters do we have. I know it sounds very vague, but this is what we do. So one of the way of identifying those those domains is to look at into individual variables and try to identify the boundaries. So edge cases. For instance, if you have some number that is supposed to be positive, the obvious edge case will be 0. You will also try negative to see if that it is not accepted. You will try to the maximum, maybe integer or long or whatever. How many bytes do you have for storing your value? So, but the most interesting is how different variables work together at input variables work together at producing a different kind of outputs. Similar thing is a combinatorial testing that we are trying to just identify all the possible meaningful values, different values for each of those parameters, and then we use combinatorics to kind of produce a huge list of the combinations of those parameters, which each combination is basically their test case, the test data for a test case. Also, the last and I would say the least understood and least used approach is called model-based testing, and here we're trying to model how our application works. For instance, we can try to use the state machines to represent the model of our system, so that say that the system can be in a big number of different states, and everything that you can do with a system is you are transferring it from one state to another. And if we try to build a graph and try to visit every vertex of that graph, every edge of that graph, we can say that we kind of tested all the possible scenarios that we can do in this system if we assume that our model is correct. So and there are tools actually to do exactly that, but it requires modeling, and frankly, I never saw that it would be used for commercial software. It may be used for something like, I don't know, aviation industry, space or something, but never saw it in real life. Okay, so I think it's time to see in practice what we are talking about when we are talking about the code coverage and how we design our tests. So let me share with you this link. You can open it. Second. And I mentioned mutation testing. And in this demo, we will compare the regular code coverage with mutation code coverage. For mutation code coverage, we will use a tool called Striker for JavaScript. It's not very sophisticated, but or very performant, but it is a really nice tool to demonstrate how mutational testing works. So, and they describe pretty well how it actually works. It just have a certain number of mutators, so what they call mutators, which is actually the operation they do on the code, on the particular line of code, to mutate it, and then they run tests with this mutant and see if it passes or it fails. So I suggest that you can quickly look what they can do. So replacing true with false, replacing plus equals with minus equals, etc., etc. Removing the functional blocks, changing greater with less, or with or conditions with true and false, etc. Okay, so let's go back to these examples. I suggest, so there is just two files here. It is the the code that we will be testing. It is a pretty simple set of classes that represent the suite of cards. And in this case, we are implementing the class called set of cards, which can be, for instance, the player's hand. So you have a certain number of cards in your hand. What you can do with them? You can take some cards from the other set, from the table, for instance, or you can put some cards to the other set, for instance, on the table. You can check if you have certain card, you can check if you have cards of certain suite, of certain rank. You can check the card with which highest rank do you have for particular suite or at all. For instance, if say I have ace, this will be always the highest rank. From the other hand, if I'm checking, for instance, if I have what is the highest rank for spades, and in spades I only have 2, then it will be obviously it should return the two of spades. So I suggest you look at this code, and obviously it has some bugs. This is what we can expect. Also, we have test cases that tests this class. So this is the simple just tests. Here we have TypeScript here, as you can see. So the tests are just testing each or maybe some of those methods individually and checking they're having sometimes multiple assertions in each test, which may be not very good, but it is very concise and we don't have too many methods. So you also can take a look. And if you see something strange, if you see that maybe we are missing something, please write it down and see if we find everything. And if we don't, let me know. Okay, so let us go to the Visual Studio Code and try to run some tests. Okay. Okay, as you can see, we have 100% statement covered, 100% branches covered, 100% functions covered. So each and every line is covered with tests. This is nice. So if I am developing the unit tests, I would probably say that, okay, I have 100% code coverage. Usually the threshold is 80%. So we're good to go. Let's commit code and forget about this piece of code completely. Okay, let's try to see how good our tests are. And to do that, we will run Striker. It will take quite some time because as you see, it is creating 68 mutants. What does it mean? It mean that it compiles code 68 times and it run tests 68 times. All the tests. Guys, and please, if you have any questions so far, or if you find anything, any issues with what I'm saying, anything not clear or not correct, let me know.
Mike.
Yep.
I have a question while we're waiting for it to run. What are the limitations with Striker? Is there any, let's say there's a piece of code that has been compiled or something, or is, you know, minified, uglified, or whatever, and you want to test that? Would that be possible with this? Or
I don't think it would make much sense. It would be possible, but you probably don't want to do it. Because the main thing is the report. You would want to see the report. You would want to see what is broken. It's not just number. So, okay, we have actually the report. We see there are 2 mutants that are survived. So one is on the line 94. Okay, that's interesting. So our we have a function that is checking if we have this card. And we are actually checking the equality of our card that we're looking for with one of the card in our set. And what? If I replace it with this, it will still work. What does it mean? Let's see the test that we have for this functionality. We don't have, for instance, 8 of any other color of any other suite. We are not testing the second expression. So how would we fix it? Okay.
Now, as a non-engineer, what does a mutant do? Is that like a break in code? There would be something wrong.
It is changing. It is changing the code. So you see the line 94.
Okay.
So this is what it used to be. And this is what how the Striker changed it.
Gotcha.
So it changed it and they run tests again to see will the tests find this change in the code, or it didn't, because this change is obviously introducing a bug.
Gotcha.
I really think that now we should have it. Let's see.
Do you always have to run the test before you run the Striker?
To make sure that we didn't break anything. So that this test actually passes, because if it fails, it doesn't make any sense. So Striker, it makes sense to run Striker only after you run the test. Because otherwise, it is not clear what you are testing.
Gotcha.
because the test will fail before executing all their expectations. So it will not run all the statements that it would if the entire test will be executed in the first place.
Gotcha.
And in the second place, the test will be always failing, so we cannot identify that the mutants actually work or not.
Understood.
Because the mutants work if the test mutants is not killed if the test is passing. If it is always failing, then kind of work.
One survived.
Okay, very nice. So we fixed it finally. The problem
Woo!
was that we
Teenage
didn't have
Ninja
enough.
Mutant Turtles.
Yes, we didn't have enough tests for falsy. Okay, this is very nice. Let's see what's wrong with the other one. So this is the code, and let's see how we test it. I think we don't have enough test cases here. Moreover, let's look into our set of cards. It has just 2 cards, just 2 of them. I don't think it's enough. Let's reuse our nice set that we created and see if it can solve the same problem for us. Okay. So set 1. Set 1. And okay, so what is the highest rank for the clubs now? Do we have any clubs?
No.
No, we don't have any clubs.
No clubs.
Interesting. And what will be if there is no clubs? It will return 0. And what does 0 mean? I have no idea what 0 means. So here we are actually getting to the first thing of the important thing of the test design. First thing that you do is you're trying to understand the requirements. So what is the requirement for the highest rank? What should it return if there is no card of this suit, or there are no cards in our set at all? What should it return? I think 0 is obviously incorrect because there is no rank of 0. The rank starts with 2. I think that we need to rewrite it. I think that the correct thing that it should do is to return null, or in JavaScript lingo, undefined, in case if we don't have a card. So how we do it? Okay, I would say that if highest rank so far is 0, we instead will just return
Undefined.
undefined, and that's it. Okay.
Look at me, I'm becoming an engineer.
Yes. Well, you hosted so many lightning talks that it wouldn't surprise me.
I'll go take CoderPad.
Okay, so what we have here? Oh, that's interesting. The condition, the problem here is that it thinks that run cannot be 0. Yeah, of course it cannot be 0 because it is not ranked. Okay, let's go ugly. You know what? Now it can be 0. But this is not how you fix your code on production. It is absolutely not.
This is the ugly way to do it. This is the Gen way.
Okay. We just tell it, okay, you know what? You may think that the rank cannot be 0, but I'm telling it, this particular rank is 0, whatever you do. And this is how, and you see this interesting thing. It was not complaining when we assigned it a 0. How we were even able to do it? Well, this is how enums work in our TypeScript. This is really interesting. Okay, so let's go back to our tests. So first thing I will do is here the highest rank of clubs, I think, should be undefined, right? So what is the highest race, the highest rank of hearts? I guess it is ace, right?
Yeah.
Okay. And highest rank of diamonds, where we have only one card, is Jack. Okay, so it is here.
That's
we have the
misspelled,
heart.
Mikhail.
This is hearts. Oh, sorry, Jack. I didn't mean to offend you.
I don't want to break your, I don't want any mutants.
Okay, so those are diamonds because we have diamond Jack. Nice.
Woo!
Let's see what is going on with our striker test. So this is exactly the thing that with the rank of 0, it is the question of how we are going to approach of what is our input for designing the test cases. Our input should be the requirements. So first thing that we need to check if the requirements make sense. And what a function should return in the different cases. Actually, it makes sense to just review do the code review, look at the function, and try to understand what it will return in the different situations. So as you saw, the plain test coverage definitely wouldn't help finding it, and even Striker didn't, because this is what I found just looking at the code, not something that Striker suggested me to fix. Okay, so now we have 100% of the coverage, but did we fix all the bugs? Did we find them? Let's look at our sort function. So I think we should have sort here. Do we have sort here? Yeah, we do have. So how does it work? We have a function, the comparator function, that tries to kind of just give each card a value so that they can just be ordered in particular order. So what is this order? Okay, so how enums work? It just, so if we start with 2, then each next one will be +1. So it will be 3, 4, 5, 6, 7, 8, 9, 10, queen. What? I think that after 10, we should have Jack, don't we? How interesting. Did we find this bug? No, we didn't. Why we didn't find this bug? Because we didn't actually check. And the Striker couldn't help us because this is actually the problem with exactly classes of equivalence. So how can we check the sorting? How can we check the function that is returning us the highest value if we have enum? Unfortunately, the only way is to check each and every item here. There is no other way. So in this case, if we tested with using the classes equivalence, we will say for the means of sorting, all the cards are different. So we need all 52 cards, and we need to sort them. And the same comes with our highest rank. So we need to compare each and every card with each and every other card. This would be the only way to find it. Okay, let's see if we broke anything by fixing this. That doesn't still work. What does it mean? We changed very significant thing, the order of cards. And we have two functions that actually care about orders of cards. This is sorting, and this is highest rank. But you see, the test is still passing. Why Striker didn't do it? Well, because it doesn't have this mutator. So the mutational testing is as powerful as many different mutations will the tool have. This is also an important thing to understand. So obviously the Striker will return the exactly same result because we didn't change, because the tests are still failing and we didn't change anything. Okay. And we changed the order of ranks. What will happen if we change order of suites? How do you think? Which test will fail? Any suggestions?
I don't know.
So I would, by logic, it should be sorting, right? By logic, because we are changing how this, because highest rank function, it is checking the rank. It have nothing to do, not too much to do with the suites. So, but the sorting, it cares about suites because it have them in certain order. So let's see. Okay, so interesting. So let's run the test again and see which of them fails. Okay, so some test fails, and which of it? That is amazing. So for some reason, the test that failed is highest rank. Why? Why was it highest rank? Okay, let's see the code of the highest rank. Okay, what are we doing here? So if we don't have a suit, then if we do have a suit, then the cards are the cards of the suit. If we don't have the suit, the cards are all the cards. Okay, but what does this check actually does? So suite is what it is. Let's see. So suite is an enum. And which values it have? You know what? This is actually what value it have. So clubs is 0. So what are we checking here? Actually, we are checking that it is not clubs. Why we do it? Well, because the JavaScript guys usually do it this way. So they think that if they check their variable for to be true, they check if it is undefined. The problem is that also it can be 0, which also relates to false. And the 0 is exactly the value of one of our suits. So what should we check here? We should check explicitly that if suit not equals undefined. This is what we should have done actually. Okay, let's see. But interesting thing, sorting didn't fail. What does it mean? It means that, again, we'll lack enough tests for sorting. Okay, so let's run the test and see if they pass now, because we fixed our application. Okay, they do.
Woo!
And what happens with Striker? So guys, actually, this is the end of, of this part. So I think you'll see the point that I'm trying to make. The test coverage is nice.
It's awesome.
The code coverage is nice. It wouldn't reveal all the bugs. The mutation coverage is even better. It will let you see which some of the tests which are actually missing, because you will see some of the bugs that will not be revealed by your test. The problem is that even the best mutational tool cannot kind of create all the possible bugs on Earth in your code. It is not possible.